Good day everyone, welcome to today's chemistry class. Our topic for today is metals and their compounds, and I, Ibrahim Olawoke, will be taking you through this session. To begin with, let's talk about the general properties of metals. As we all know, metals are solid but at room temperature, except mercury. So mercury is a liquid at room temperature, but all other metals are solid. Then another property is that metals have high melting point, except for sodium, which melts at 98 degrees Celsius, and potassium, which melts at 62 degrees Celsius. Generally, metals are good conductors of heat and electricity. They have high densities, except for aluminium and magnesium. Metals are malleable, that is, they can be hammered into several sheets and be forged into different forms. Metals are ductile, that is, they can be drawn into wires. Let's look at the chemical properties of metals now. Firstly, metals ionizes by losing an electron, thus they form a cation. For example, you have sodium plus, that plus is the ionization, thus it ionizes by losing one electron. Let's say calcium 2 plus also ionizes by losing 2 electrons. So metals react with oxygen to form oxides. For example, sodium oxide, calcium oxide, and so on. They react with dilute mineral acids to liberate hydrogen gas. Example of mineral acids are HCl, hydrochloric acid, H2SO4, sulfuric acid. So when zinc, for instance, reacts with H2SO4, it gives zinc sulfate, then liberates hydrogen gas. You can see hydrogen is given off. They form ionic compounds with non-metals. What are ionic compounds? Thus, when they react with non-metals, they share electrons. For instance, you have calcium plus chlorine to give us calcium chloride by sharing of electron. Next, let's see the activity series of metals, or sometimes called the reactivity series. Now, looking from the top, we have potassium down till gold. This is the activity series of metals, and this determines how reactive it is being arranged in terms of the reactivity. Now, the highest, which is potassium, has the most reactive nature, while the least reactive is gold. There is a way you can recall this simply. I'm going to say it now. You can start from potassium using the first alphabet. Now I'll take it like this. Popular scientist can make a zoo in low humid country more satisfactorily good. Let's take it again. Popular is for potassium, scientist sodium, can calcium, make magnesium, a aluminium, zoo zinc, in iron, low lead, humid hydrogen, country copper, more mercury, satisfactorily silver, and good is gold. So that's a shortcut for you to remember this. You don't need to cram it. Let's go to the corrosion of metals. Corrosion literally means rusting, and we all know all metals corrode, that's the rust, except gold, silver, and platinum, which are all resistant to corrosion. So this is one of the properties that metals also corrode. And what are the uses of metals? Generally, metals are resistant to corrosion. They are malleable, ductile, and lustrous. That's their shining nature. So they can be used for decorations, making jewels and coins. Examples are copper, silver, and gold. They can be used to make alloys also. What do you mean by alloy? Alloy is the combination of two or more metals to form a new compound. For instance, we can add tin and zinc to get a new compound, and so on. So let's look at the method of extraction of metals. How do we extract metals? Since metals are not found pure in nature, thus they always exist with impurities, and these are called ore, except for silver, platinum, and gold, which are pure in nature. Now, the three reduction methods include, we have the electrolytic reduction in terms of electrolysis, then we have the reduction by coke, that's heating in the presence of carbon, and that is coke. And last, we have a thermal reduction, that is roasting in air. Now, the extraction of every metal depends on the position in the activity series. Let's see that if you look at high in the activity series, potassium, sodium, calcium, magnesium, and aluminium are extracted using electrolysis because of their high reactivity. Then zinc, iron, tin, and lead are extracted by burning in carbon, that's coke. Then copper by burning in air, while silver and gold are pure. They don't need to be extracted. You can get that in nature. Now, our homework for today is, what is the term used to describe the ability of metals to be hammered into sheets? You just take the term. Then you have to mention one metal which is liquid at room temperature. This is a wide question. Next, arrange the following in order of increasing reactivity. That's following the reactivity series. We have the gold, zinc, magnesium, sodium, aluminium, calcium, lead, iron, copper. And you have to state which of the metals can be extracted by electrolysis. Is another wide question. Thanks for listening.